So today we're going to be going over the second part of factoring. Now what we're going to notice on every question here today is the fact that each one of the things that we're expected to factor doesn't have four terms, so we can't pair them up and pull out the GCFs like we did beforehand. This is going to be a different type of factoring. And what we're going to be doing here is we're going to be splitting the middle term into two, because in essence what we see is we see three terms, 1, 2, and 3. And if we split that middle term into two, that's going to allow us to group the first two and the last two. But how do we split this? So if we jump into number 1, let's take a quick look and see what thoughts are going through our head. So if I split this 9, I've got a couple options that I could split. I could split the 9 into a 1 and an 8, a 2 and a 7, a 3 and a 6, and there's lots of combinations. I could even flip it around into like an 8 and a 1, a 7 and a 2. How do I do this? Well, here's what we're going to do. Let's go ahead and identify first off our A, our B, and our C, because we're going to be referencing those throughout this whole lesson. The A is the number that's in front of the x squared, which in this case is going to be a 1. So our A is equal to 1. Our B right here is the number in front of the single x term, which is going to be a 9. And then our C is this number out here, which is going to be an 18. Now, what this method entails is we need to multiply the first, our leading coefficient, times our constant, so our last number, so A times C. And when we do, let's do this over here. And let's get rid of this old sketch. So when we multiply A times C, we get a positive 18. Okay. And then what we'll do is we're going to go through and we're going to list every possible factor of 18. So I know that I could do 1 times 18. I could do 2 times 9. I could do 3 times 6. I know 4 doesn't work, and 5 doesn't work. And 6 I already have on the table, which means there's no other factors in here. And this is what we call closing the loop, because I know that 4 and 5 don't work. The next number, 6, is already on my list. So there's no other factors other than these three. So the loop is closed. It's got to be one of these. Now, what we're going to do is I'm going to take these numbers and I'm going to add them together. Why add them together? Because of the sign on my 18. The sign on my 18 is addition, which means sum. So 1 plus 18 is going to give me 19, 2 plus 9 is going to give me 11, and 3 plus 6 is going to give me 9. So I've factored the 18, and I've added the factors together, and what I'm looking for is I'm looking to see if I can't make that middle term. And you'll notice that that is going to be the case. So I'm going to split my 9 into a 3 and a 6. So let's rewrite this question, but instead of writing the plus 9x, let's write plus 3x plus 6x. X squared plus 3x plus 6x, which we know is originally 9x. Perfect. And so when we do this step, that gave us our 4 terms. Now we can do what we already know how to do, and we can pull out our GCFs. In this case, it's going to be an x, which will leave me with x plus 3. Over here on the right, if I factor this out, I can pull out a 6, which will leave me with, again, an x plus 3. And then I notice that both of these expressions have an x plus 3, so I can go ahead and I can pull that out and say, let's pull out an x plus 3, which gets rid of that. And what I'm left with is I'm left with an x plus 6. And there we go. So now this expression, if I were to FOIL this together, would produce my original equation. And let's go ahead and let's double check that real quick. So if I multiplied x times x, I would get x squared, x times 6, 3 times x, 3 times 6. Combine my middle two terms, x squared plus 9x plus 18. Yes, my answer does check out. So the whole trick right here is we're going to take that first leading coefficient and the constant, multiply them together, and create a list of factors. And that factors is going to tell us how to split that middle term. Once we split it, there's nothing new going on with this problem. So let's take a look at number 3 real quick. So again, our first step is to identify our A, our B, and our C. Now this time when I multiply A times C, I'm going to get a negative number. So A times C is going to give us 1 times negative 21, which is a negative 21. I'm going to go ahead, ignoring the negative, list all possible factors of 21, which is 1 and 21. 2 doesn't work, 3 and 7, 4, 5, and 6 don't work, and then I've closed the loop, which means my next number would be 7. So my only 2 sets of factors are those. Now, unlike before, because my number was a positive, and I added these up together where I would get 22 and 10, this is a negative, so I'm not going to do that. I'm going to take the difference between them. So the difference between 21 and 20 is going to, or 21 and 1 is going to be 20. The difference between 7 and 3 is going to be 4. And I'm looking to see, can I make that middle term? Yes, I can. So I'm going to split my 4 into a 7 and a 3. I bet you didn't think about that one when we were looking at the previous one. We can split the 4 into a number that's beyond it. So it's not just 4 and 0, 1 and 3, 2 and 2. I can make it a 7, and that's a negative 3. Now I've got my 4. So let's go ahead and do that. So y squared plus 7y minus 3y, which would combine to give me the 4, and then minus 21. Okay. Then from this point forward, it's just the same old thing that we've been doing. I go ahead and I divide my leading, or I divide by my common factor over here. Pull out a y, so I'll be left with a y plus 7. Over here, I'm going to pull out a 3, but I notice because that's a negative, I'm going to pull out a negative 3, which is going to make this a y plus 7. Luckily, both my binomials here are the same, so I'm going to pull out a y plus 7, which cancels that out. And I'm left with a y minus 3. And there we go. And again, if you always want to check your work, make sure we did factor that correctly. I could go ahead and try and FOIL this, which would be y times y times negative 3, 7 times y, 7 times negative 3, combine my terms. Yep, that answer does check out. Perfect. So we've seen 2 examples of that. Why don't we go ahead and try the next one? Now, the only difference we notice with this next one is that my leading term has a leading coefficient that is not a 1, which means when I identify my A, for the first time, my A is a number other than 1. My B and my C work the same way. I have a B of 9 and a C of 10. I'm going to multiply A times C, which in this case is going to be a 2 times a 10. It's the first time we're seeing something other than a 1 pop up. But the process is exactly the same. I'm going to do factors of 20. One of the tricks that you may have seen if you factored in a different method is a lot of times when A is 1, the method is to say just go ahead and list factors of C, which works out pretty well, but only if A is 1. And then there's a completely separate method shown here, but by using the method that we've shown, it's consistent throughout all different types of problems. So here we go, all possible factors of 20. 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, and I have closed the loop. I know because 20 is positive, I'm going to be adding these things up. So 21, 12, and 9. I'm going to look to see, do some of them make a 9? And the answer is yes, right here. So I'm going to split that 9x into a 4x and a 5x. Perfect. And now from this stage forward, I can go ahead and I can pull out my GCFs. 2x, which leaves me with, let's see, an x plus 2. Over here I can pull out a 5, which will leave me with, again, an x plus 2. that common binomial is x plus 2, which means I can move that over here. And I'm left with a 2x plus 5. And there we go. Now again, we could verify this by going ahead and foiling that. This will be the last one that we actually do physically check, because I think we'll get the process after this. But if I foil this, I'd get x times 2x, x times 5, 2 times 2x, 2 times 5. Combine my middle two terms, I get 2x squared plus 9x plus 10, which was my starting problem. So yes, we did factor this correctly. Awesome. And so that brings us to our next few questions. So let's jump into number 7. Okay. So number 7 is the same style problem. What I want you to do is I want you to give this one a try. So go ahead, pause the video, unpause it when you're done, and see how well you did. Okay. So now that you've had a chance to try that out, let's take a look. My A is 3, my B is negative 13, and my C is negative 10. A times C is going to give me a 3 times negative 10, which is negative 30. All my factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. Because 30 is negative, I'm going to be taking the difference between them. So that's going to give me a difference of 29, a difference of 13, difference of 7, and a difference of 1. I'm looking for a difference of 13, which are going to be those two right there. So I have a 3r squared, and I'm going to split my 13 into a 15 and a 2. Now here's the deal. I need to make a negative 13, so I have two options. I can either make a positive 15 and a negative 2. That'll still give me a negative number. Or I can make a negative 15 and a positive 2. In this case, what I'm going to do is I'm going to go with the negative 15 and the positive 2 because I need my 13 to keep the sign of the negative. So let's go ahead and pop that negative right here and the positive right there. The rest of this works just the same as any other factoring problem. Pull out a 3r. Leaves me with r minus 5. Over here, I'm going to pull out a 2. And I'm left with r minus 5. Those binomials are the same, so r minus 5 can get pulled out. And I'm left with a 3r plus 2. Perfect. Awesome. And so, how would you do? We could go ahead and we could try foiling this, but again, I think we got the idea right here. You just take those numbers, multiply them, find either the sum or difference depending on the sign, split it, and then factor. Now, with questions like this, the only new thing that you might run into is, oh, I have a leading negative. So what does that do? How does that change my approach? The answer is it really doesn't. The final answer, we're going to do one little thing, because typically answers with this format are going to have one change to how we show the final product, but the whole process is going to work the same. We're going to identify A, B, and C. I'm going to work through this and say A times C is negative 1 times negative 15, which is going to give me a positive 15. I only get 1 and 15 and 3 and 5. Those are it. And because it's positive, I'm going to be summing them. I know it's going to be a 1 and a 15. So this is going to turn into a negative 1y and a negative 15y, which I know combines to give me a negative 16y minus 15. Perfect. Now, here's the deal. When I factor my GCF out of the first one, I have a leading negative, so I'm going to make that a negative y. That'll give me a y plus 1. Same thing over here. When I factor this, I have a leading negative, so I'm going to make that a negative 15. Left with a y plus 1. You'll notice that they both have a binomial of y plus 1, which allows me to pull this out. And then I'll have this thing called a negative y minus 15. Now, there's nothing wrong with this. This is completely factored. But one of the things that you'll find is that a common practice is to make sure that we don't have any leading negatives in either of our factors. It's a common thing that if we see one of these, we just go ahead and we factor that out, which means that the y plus 1 does not change. But I'm going to pull out a negative 1 out of this expression. And what's left over? Well, that negative y is now a positive y, and that negative 15 is now a positive 15. All it does is it changes that sign, so that way I have a leading positive and a leading positive. If I ever have a negative, I make sure the negatives pull out. And that is the only difference on how we work a problem like number 9. Awesome. So why don't you go ahead and try out the last one, number 11, pause the video, unpause it when you're done, and see how well you did. Okay. So now that you've had a chance to give it a shot, let's go ahead and try this one ourselves. So I have an a of negative 4, a b of 11, and a c of 20. I'm going to take a times c. It's going to give me a negative 80. Ooh, so this is going to be a big list. I can take 80 divided by 1, by 2, 3 doesn't work, 4 does, 5 does, 6 doesn't work, 7 doesn't work, 8 does, 9 doesn't work, and then I've completed my loop. So it's got to be one of those right here. I have a negative 80, which means I'm taking the difference. So 79, 38, 16, 11, and 2. I'm looking for an 11, so it's going to be this one right here. So a 5 and a 16, I need an 11. So I'm going to make that a negative 5 and a positive 16, because 16 minus 5 is 11. Factor this. I have a negative, so I'm going to make that a leading negative. There you go. I'm going to do this over here. That's going to be a 4. I get a 4x plus 5. My binomial shared is 4x plus 5, which means I can pull that to the front. And I'm left with a negative x plus 4. And now we just saw that it's not common practice. This is factored, yes, but fully factored, we tend to pull out the negative out of there, which means that my 4x plus 5 remains unaffected. But after I pull out this negative 1, I'm going to be left over here with, let's do this, an x is now positive, and that 4 is now negative. And that's going to be the final form that we show our answer in. And there we go.